Hello class and welcome to another exciting facilitation for this semester. I am Dr. Annie George, Department of Public Health, Faculty of Health Sciences, and will be your guide. Hope we all enjoy it. Thank you. So welcome to another class this week on topic 7, measures of central tendency. At the end of this lesson, we're expected to know bar and pie chart, as well as histogram and ways of presenting data in a diagram. We should also know how to calculate the mean, median, and mode as measures of central tendency. So, diagrammatic presentation of data. Well, we'll start with this. Even though we're going to go into central measures of central tendency, let's round up with diagrammatic presentation of data. And the forms of diagrammatic presentation of data is bar chart, pie chart, and histogram. So bar chart is usually used for categorical variables, is in form of a rectangle with lengths that are proportional to the frequencies and magnitudes of the variables that are presented. Usually 2 or more bars that are drawn adjacent to each other and could be presented in percentages. So we'll start with frequency table. You remember in our previous class we talked about the class, the serial numbers, and the frequency table as appearing in 3 columns. So you can see this will help us to draw those charts that are represented in diagram. So this is an example of a single bar chart. You could see the class 40 to 49, 50 to 59 on the horizontal axis, and then the frequencies at which they're occurred on the vertical axis. 40 to 49 is 5, 50 to 59 is about 17, 60 to 69, 70 to 79, and 80 to 89. So this is an example of a bar chart. You can see that each of the bars are on its own. So pie chart, on the other hand, is used for categorical variables like bar charts as well. However, they come in circular shape with each area in that circle representing total frequencies of each variable or each quantity you're measuring or whatever you are looking at. It's also presented in percentages. This is an example of a pie chart. You could see the frequency of 5 is presented by 10%, that of 2 is 4%, 13 is 26%, and then 13, 26%, and so on. So histogram. Histogram is basically also a graphic representation, but this time it is for quantitative or continuous variables. It's usually in rectangular forms with lengths proportional to the frequencies or magnitudes of the variables that are presented. The area of each rectangle is proportional to the frequency of observations in each class, and the width of each rectangle is fixed and equal, representing the class interval of the variable that you're measuring or you're presenting. This is an example of a histogram. So you can see the difference between histogram and bar chart. Histograms are continuous. The bars are actually aligned to each other, as compared to bar chart, which is single and separated from one another. In histogram, they are aligned and they are used for continuous quantitative variables, while bar charts are used for categorical variables. So this brings us to measures of central tendency. What are the measures of central tendency? The measures include mean, median, and mode. These are terms used when measuring central tendency. So we'll discuss them one after the other. The mean. What are the characteristics of the mean? Mean is usually the center of gravity, the average. All observations are used in its calculation, and it's affected by all values, and also affected by fluctuations in samples. Is also the most reliable best measure of central tendency. Is not necessarily a value belonging to the group when you calculate it, and cannot be used when handling qualitative variables. It cannot also be calculated if a single observation is missing. So mean can be in ungrouped data. It can also be in group data. In ungrouped data is basically a summation of all the observations that you have found divided by the total number of those observations. In group data, you take into note what you call the summation of all the groups, the class frequency, the midpoint value of each of the group, and then the total number of observations, what we call sigma fx over n. So we'll look at examples of how to calculate the mean in ungrouped data. So you have 1, 2, 3, 4, 5, 6, 7. If you sum all that, you have 28. The number of observations here are 7. 1, 2, 3, 4, 5, up to 7. They are single numbers. So if you divide 28 by those number of observations, you have 4 as the mean. Also, in ungrouped data, you can have numbers appearing twice, like 1 and 2, 2 appearing twice, 6, 6 appearing twice. So you have 1, 2, 2, 3, 4, 5, 6, 6, and 7. So the total number of observations here, they are 9 in number. So you count the double numbers here as, double observations. So the total number of observations 9, but if you calculate the total, the sum of all those observations, they are 36. So the mean here will be 36 over 9, which is 4. Now, let us look at mean in group data. Remember the example we've always shown, the frequency table. So in calculating mean in group data, you have to look at the frequency table. Like we said, we have class of 40 to 89, 40, 49, 50, 59. We have 5 classes here as represented. And then the class center, which is X, is 40 plus 49 divided by 2. You take the average of the sum of the classes. 40 plus 49 divided by 2 will give you 44.5. 50 plus 59 divided by 2 will give you 54.5. So that's how you do it until you get to the last fifth one. So the frequencies at which they appeared is 5, 17, 13, 13, 2. Now fx is calculated by multiplying the class center x by the frequency at which they appeared. So 5 times 44.5 will give you 222.5. 54.5 times 17 will give you 926.5, and so on to the last one, which is 84.5 times 2 will give you 169. The summation of fx will give you 3,125, and the summation of the frequencies n will give you 50. Now in the next slide, we will have an activity. So activity 1, calculate the mean. Remember, the mean above is sigma fx over n, like we said. So use that formula to calculate the mean. Okay, so imputing the figures into sigma fx over n. Remember, our summation of fx is 3,125 and n, total frequency, is 50. So if you divide that, you have 62.5 as the mean. which means the mean falls between class 60 to 69. This brings us to another measure of central tendency called the median. What are the characteristics of the median? Median can be used while dealing with qualitative variables. Remember, mean is mainly in quantitative variables. Here, the median can be used in qualitative variables. Is a better index for describing average number of cases of communicable diseases which have well-defined cycles. It's a better average in also describing the trend of an illness over a period of time, including epidemic years. It cannot be determined directly for even number observations and is not based on all observations, unlike the mean that is based on all observations. It is not affected by outliers. So median can also be in ungrouped data. So the middle number is usually the median in a set of ordered observations, ending with an odd number. Example 1, 2, 3, 4, 5. There are 5 numbers here. So it means it's not ending in even number. It's ending in odd number. So the median here will be the middle number, which is 3. 1, 2, 3, 4, 5. In even number ending, however, when 2 middle numbers exist, the average will be 2. The average is, you take the 2 numbers in the middle and take their average. That will give you the median. Like here now, you have 1, 2, 3, 4, 5, 6. So the middle numbers here is 3 and 4. So you take the average. So the median here will be 3.5. So we have median in grouped distribution. Median in group distribution. So you can see serial number 1 to 5, class, and then you see the class center X, the frequency, and the FX, which is the total. So here now, what is the middle number here? You divide the frequency, which is n is equal to 50 over 2. That will give you 25. And if you calculate the frequencies, 5 plus 17, you'll find out that 25 will be between 60 and 69. It will fall at the frequency 13. That is where the 25 is, and that is the median. So the median is between 60 and class center 65. Between class 60 to 69. Class interval 60 to 69. That's where the median falls. So another measure of central tendency is the mode. The mode is the highest frequency in a distribution, the value with the highest frequency, or the most occurred number. It can be unimodal if one value has the highest frequency, or bimodal if 2 values in the distribution have highest frequencies. So further characteristics of the mode: it does not exist if all values in a set occur with the same frequency. So if all the values occur with the same frequency, there will be no mode. Is not affected by outliers. It gives the point at which the observation cluster and converge. It may have multiple values and is not based on all observations, unlike the mean that is based on all observations. It is used when most repeated variable is wanted and is also affected by fluctuations of sampling. So mode in ungrouped data. You have 1, 2, 2, 3, 4, 5, 6, 6, 7. So mode here is the most occurred is 2 and 6 because they occur twice. So this is an example of what we call the bimodal distribution. In the next slide, we will have an activity. So activity 2, calculate the mode, in this case, grouped distribution. So you can see the class, you can see the frequency at which they occurred, and then the total fx, sigma fx, which is 3125. So let's look at how to calculate the mode in this grouped data. So if you look at it, in this mode, in this table, the class interval with the highest frequency is 50 to 59, which is 17. So the mode is actually between 50 to 59 class interval. That is the mode because it has the highest frequency, 17. So in sum, we learned the use of bar and pie charts and also histogram in diagrammatic representation of data. We now know how to calculate the mean, the median, and mode as measures of central tendency. In the next lecture, we shall discuss measures of dispersion. Thank you for listening.